So please put your hands together for Abby and Jared.
Hello. Is this on? Check. OK. So this is Weedmaps, and this is how we became more agile as an organization. And it's a journey by Weedmaps. I pushed the button. All right, probably just have to do this. Oh, is the computer frozen? Dang it. Technical difficulties. Why is it present? So who are we? I'm Abby Malson, engineer and developer at Weedmaps. You can find me on Twitter at Abby Malson.
And I'm Jared Keith, engineer at Weedmaps. You can find me.
So where are we currently? We have multiple releases a day. We have stats for the quarter listed right there. The week before our code freeze for 420, we had 43 releases in a week. The average release size for those 43 releases was about 5 commits each. Over the past quarter, we have averaged 5 releases per day to production. Code lived out on our staging environment for less than 15 hours. As you can see from the stats, it was 12 and a half. And over 20 different production services are controlled through our build automation. We have 10 different developer teams, 100 different engineers dedicated to application development, and monitors and runbooks to help us get online in the event of an outage. So there are 3 pillars of a mature DevOps organization that I found off of an article. A culture of collaboration and trust, a focus on automation and tooling, a commitment to measurement and continuous improvement. So there's this whole thing about the virtuous cycle of agile DevOps. Basically, the stats aren't important, other than they just mean that you do better. But it's automate some stuff, reduce incidents, free up people's times, pay back some technical debt, and improve quality. Let's take a moment to talk about Conway's law. And I'm not going to read that, but basically if you suck at talking to your coworker, it will reflect in the applications that you build as an organization. So yeah, get better at talking to your coworker.
So every journey has a starting point, and ours starts on one of our worst days in our company history. We quickly found if you don't test, your customers will. If you think about it, we are a tech company in the cannabis industry, so 420 is a pretty big day for us. On 2016, we had a few of our customers call us. And as you can see from the screenshot, we were very unhappy. Our site was down about 7 hours, so this stuff still happens today.
Oh, sorry, yeah.
And how we got into this issue or this problem was a solution, at least we thought. We tended to throw money at things, threw money at everything, and that tends to get you into some deep holes. We got ourselves to the max instance size that we could get on AWS. So instead of addressing performance issues and fixing our application, we just got a bigger instance size. And we couldn't do that anymore, so we were in a very, very bad place. And we basically had no application monitoring. We had our base level Amazon monitoring, but there's very few developers that could go into AWS and actually look at that. So we had very few people that could actually diagnose application issues, and that was also a huge problem.
And as you can see, we had some problems that we had to tackle as a company in order for us to grow. Our infrastructure was a bit of a nightmare, as you could guess. I pushed the button. We had a general lack of confidence in our quality assurance testing. We had overall lack of monitoring, as you could tell. And we just rather sucked at communicating as a company, so we tried to do better.
So one of the first things we identified was our infrastructure that needed to change. And we made the initial decision to have an outsourced infrastructure team. It's kind of a wonky thing to have as an outsource. Works great when you're really small, but when you're big and you're scaling fast, having a contractor essentially control your destiny creates a lot of issues downstream.
So one of the things that we started to do was to bring our infrastructure team inside the company so that we could respond quickly to outage events and get our systems back online quicker than we could with the outsourced infrastructure.
So part of this lack of consistency was this contractor team read new articles on cool Devops things. So we ended up with a different strategy on every stack. As you can see from the screenshot there, we got a bunch of good tools when we came in 2016, but they were being used in various manners. You really didn't have any consistent infrastructure. Everywhere from minified code on vanilla EC2 to using Offsworks or Engineer or anywhere in between. You name the tool, we might have had it. The key thing is we had no consistency in our infrastructure. It sprawled everything.
So because we brought our infrastructure team inside the company, one of the first things that they started to do was to build out our infrastructure and configuration. We built it out in code with the tools that we knew and loved, which was Circle, Terraform, and Chef, and of course GitHub.
So with this lack of consistency, you bet our environments were all over the place. And it was really whatever tech lead was running that stack and whatever they went and favored, that's what they would do. In some cases, they cut off master, deploy to staging just to make sure it deployed, and then go to production for zero testing. In some cases, we'd go through the whole gamut, test, develop, acceptance, staging, demo, performance, production. Again, the only consistent thing is none of our stacks shared one single environment.
So in order to make our infrastructure a little bit more stable and to be able to duplicate what's happening on production in lower environments, we put everything into containers. And this allowed us to make sure that things were consistent all the way through. And we use Docker and Rancher to get our applications to production.
So lack of consistency theme, again, a tech lead, whatever they were reading about that day was the branching methodology that they put in place. And so you had a lot of people spending a lot of time managing merges, tags, release notes, cutting releases, and it just, you really can't port a build process if your branching is just all over the place.
And what we did was we used Ref Spectacular. You can see the link right there. But basically, we ensured that the same SHA was used on our acceptance environment, was used on our staging environment, was used on our production environment. And that way, we at least had an idea that whatever we stamped as gold standard going to production would stay the gold standard because we didn't have to manage the different production branches.
And so with this lack of consistency, our deployment methods were really all over the place. Some developers would SSH into a box and run a migration and then bounce over to another box and do a dabbit blast. And in some cases, Git and Circle would run the flows. In some cases, you'd go into Opsworks or Engine Yard and push a button. Really, there was no single method throughout our system. We used rolling and blue-green, and it was a mess.
And because we were consolidating everything, because we brought our infrastructure team internally, we noticed that blue-green deploys had the least amount of traffic impact on our production traffic. So we consolidated all of our stuff toward using that deployment method.
And so our quality assurance was pretty appalling. One of the first things I did when I came in was ask the developers what kind of QA testing they had. And they said, well, we have 100% unit tests. Why do we need QA? So, you bet we didn't have performance tests. We didn't have synthetic monitoring. We didn't have smoke tests. We didn't even have a test case manager. So we had a huge gap when it came to the QA world.
So we started to test we started to automate our mainline happy paths. This allowed our QA to start testing the edge cases. And once we did that, we were able to automate the rest of our workflows because we were able to free up our QA to allow them to test things more efficiently.
And another problem we had was these giant monolithic applications where you had many developers committing into one repo. So even if we wanted to release after 3 days, let's say, you might have 20, 30, 40, 50 commits. So it made it really hard to release, and we became afraid of releasing. In fact, we went into this 2-week release cycle, And what ended up happening was we'd have a big giant release and then hot fixes, and then big giant release and hot fixes, and then compound that by number of repos you have, and you have a giant mess.
So to get out of the hot fix and release cycle, we started to release early in much smaller batches. And this allowed us to have smaller test sizes, allowed our QA to be a lot more confident about what they're releasing. And if we saw something, and because we were releasing so much closer to the head of develop, we were able to release fixes to production a lot faster.
And so we had a severe lack of monitoring. We had some infrastructure monitoring, but our offshore team didn't really care about that. They let us take care of that. So once ops came internal, they did a really good job of bringing in Datadog and introducing some base infrastructure monitoring, but we still had no visibility into our applications. Some developers might be keen on some stuff in New Relic and using that to kind of triage it, but really, like, we didn't have any monitoring.
So we started to standardize our Datadog dashboards so that the same dashboards that we expected on one graph would appear on another application's Datadog graph. We did that first, and then we created a production overview board. Because we had so many different microservices, this allowed us to see the overall application health, and so we could see when our application started failing and started having problems. We could fix that faster than because reasons.
And so we weren't emitting metrics, we weren't collecting them. You probably guess we weren't performance testing, and we didn't know how much traffic we could handle, as evident on 2016 when we fell over. So knowing how much traffic you can handle is pretty important, and we really had no clue on that. We didn't know how to performance test, we didn't know who was responsible for that. So you should know how much traffic your applications should be able to handle.
And because our infrastructure team was brand new into the organization, one of the things that they introduced, because they knew that we didn't performance test, one of the things that they introduced was Go Replay. And this allowed us to copy whatever was running on production, copy the traffic down into our lower environments so that we can simulate how our traffic patterns would emerge. This allowed us to test things like 1x, 2x, and 4x traffic along our most common paths that were in production. We eventually outgrew that because we started to have so many microservices, it didn't scale. And we graduated to BlazeMeter, and this allowed us to target our performance tests so that we could test at higher rates as well.
So yes, knowing how much you can handle, having some measurability is nice, but if you don't know how to alert or monitor, you're going to end up with a lot of customers calling us. And that's essentially how we monitor and alerted. We would do this multiple ways. A user would try to search on our site and would be unable to search, and they'd hit some social post, and we'd see that, and then we go, I guess we should fix that. Or we might have a listing owner trying to update their menu item and unable to do that, and something's down in the API or something, and then they call us. Or an internal salesperson trying to place a new listing on our map and unable to do that. So these are really, really bad ways to monitor, letting your customers do it for you, but it's definitely a way. You know.
We eventually got better at that. So we started to create some internal promises between our applications. And to do that, we used Uptime and Datadog. And this allowed us to know when our applications is suffering. And we piped those alerts that were happening into Slack and PagerDuty because most commonly our developers were hanging out in Slack rather than checking their email. And PagerDuty was on everybody's phone, so if there was an alert, everybody can wake up.
And so measuring stuff, knowing how much traffic to handle, and knowing how to alert is great. But if you don't know what to monitor on, you're going to end up with a lot of false positives. Let's put an example out there. We got this new API thing that's coming through, and we key on the 500s, and we're like, yes, we locked in on 500s, and we're like, let's do a percentage of our error rate. And so we work up this percentage algorithm or whatever, and then it's midnight, and there's less traffic, and there's 5 errors, and our alarms go off. And now you have a whole team of people waking up, and we're not correlating errors to actual application issues. So you have all these people waking up to look at your app that can do nothing, because you're not correlating actual system issues with errors. You're just measuring an error rate, and you're like, I got my errors, this is great. So really knowing what to monitor will save you a ton of time of all your people. It will also show you when your applications are actually having issues.
So we use the golden signals to actually determine what we are going to monitor for our applications. And as you can see there, it's error, saturation, latency, and traffic. And so if we release something bad, we would immediately see that traffic started dropping or error rates started spiking. And instead of tracking things like how much money our application is making, which is basically a vanity metric because it doesn't tell you anything subjective about where your errors are happening, other than just something is happening and you don't know where. This allows us to target which application is failing and figure out a fix on how to get it back online.
So because we had created this divided culture, we had this outsourced infrastructure team, our developers got used to working in this throw it over the wall world where they needed something from their infrastructure team. Well, throw a ticket over there, infrastructure will get to it, and then developers will get back to work. When we brought ops internally, this caused a lot of issues because the developers were used to working this way. So there was this lack of communication. And also, the ops team was figuring out how they needed to present expectations to developers so they knew what they needed to do to go to production. And initially there was a lot of conflict, there was oh, they are doing this, and it was the whole throw it over the wall and point at them, and then developers this, DevOps that, blah, 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 blah. And so really your communication is key. If you're not communicating with your DevOps group, you're probably going to be failing a lot.
So one of the things that we did was to create a production readiness checklist. And this allowed us to get information in front of the developer teams and the product teams so that they know that certain events had to take place before we actually release things to production. So instead of people coming to us on Thursday expecting things on Friday, we can show them that, hey, it's probably going to take at least a week in order to test the automation out. And basically what amounted to a DevOps culture shift to let them know that, hey, you should work with us more.
And so we had another issue about responsibility. So because we had this division for a long time, the first thing we tried to do is everyone's responsible for it, which ended up meaning nobody's responsible for it. So we tried to follow ops at the beginning. They did a really good job of introducing PagerDuty escalation policies and hooking Datadog monitors to these alerts and actually alerting on it. But then we, as app devs, didn't know how to actually use that. So we just copy-pasted everything that DevOps did, and then what ended up happening was DevOps had 200 monitors that they could do nothing on. They would just be like, oh, looks like it's a developer issue and you need to roll it back. So knowing who's responsible for a change in production is very key to being successful.
So at the time, our operations team had the philosophy of if you made a production change, you own the pager. And this allowed them to designate who owned pager events if something happened. Like if you push something to production, Jared is the one to fix the problem. We eventually figured out that because developers are always pushing things to production, they should be the ones that own the fixes as well, because they're the ones that are most familiar with what went out in that release. So we just gave them the pagers.
And so I'm going to talk about tickets here, and I know this is a DevOps presentation, but let's look at that example up there. You have a word for your title and a very short description for what you're actually doing. And so whoever wrote that ticket probably has a very clear idea what they're doing, and they might put a 2 on there. And a 2, whatever organization you're in, let's just say a 2 is a half a day. And so I'm expecting this thing to be finished in half a day, but let's say it takes them 2 weeks and 30 commits later and maybe 3 merge commits later into trunk. Now you have to release 2 weeks of work. So letting developers just kind of willy-nilly their tickets and run off with it makes it really, really hard to be agile because we always want to be releasing, and if you've got this big giant ticket, we can't. Now that's a 2-week release just to get that one ticket out. So having clear definition in your tickets makes it really easy to be agile.
So the way we ended up getting clear definition of tickets was by following a process called the 3 C's of ticketing. And one of our architects ended up bringing this into the company. But it's basically card, conversation, and confirmation. And card basically defines your scope in a very limited fashion. It is like, as a person, I can do this, so that I can do this. Conversation allows you to define other things that are happening within that ticket. So if you're affecting a change that's also happening in other parts of the system, you should probably have a conversation about that and define that in the ticket. And confirmation allows you to define your definition of done. And this allows you to say, okay, this is my ticket, and this is when it's done.
And we had a huge problem of where is my feature in my pipeline. We really had no visibility for outside stakeholders. So like as a developer, they might go to a QA and tell them, hey, your thing is in this environment. And so that QA just had to trust that developer. They weren't empowered, this QA wasn't empowered to go look at Circle or go look at some deployment SHA and know that that SHA correlated to this Circle build or whatever. They basically just had to trust that developer. And so sure enough, they trust that developer, they go into the acceptance environment and they test and it's passing and that's beautiful and they're happy. 3 hours later, they go to their PO, they want to sign it off, and sure enough, it's broken. And the PO's looking at that QA like, do you even know how to do your job? And like, so that system really sucks because that QA didn't know if there was 1 commit or 10 commits that came in after he initially tested and it passed. He doesn't know what team or what developer, and usually what would happen is that developer would go back in, he would dig through all the commit history and he would see that Joe Schmo's feature actually broke it and his stuff is fine and Joe needs to fix it. But that's just a really bad process of figuring out where the feature is. And now let's go to staging. So we go to staging, we put a release in staging. Let's say we say there's 7 things in this release. Well, because we sucked at our commit messages, we might not have tagged 3 of the things, so I left 3 of those things out. And now we test those 7 things, and they're all passed. QA releases it to staging, and boom, it blows up because 3 of those things weren't noted. Maybe 1 of them had a broken change in it. And like that's a really, really bad quality system. You can't validate anything, and QA is just left like always feeling like they can't do their jobs. Now let's look at a product perspective. Product's expecting this feature to come out. They have cells that are pushing on them, like I want this thing, and the developer's like, it's coming in this next release. Well, if it's not in the release notes, and it's not in the next release notes, and the next release notes, that PO never knows what happened to this feature. And the only way they might know is by going into production and testing it, and then, oh, sure enough, it's there, and they can close the ticket. So knowing where your features in your pipeline, having visibility and giving everyone visibility you need that for success.
So because we had such a specific way of how we operated as a business, we ended up building out our own build automation tool to automate some of the processes around it. And in there, we had the release notes, as well as a way for other people, rather than just the developers. We basically handed the keys over to the product team and the QA team. It's like, hey, you can release this anytime you want. And as you can see here, the little chevrons allow you to push things up to other environments. And there's also a cool little signifier to let you know when things have actually been QA'd, so that you can actually push things through the pipeline. It's pretty neat.
And so our 420s now are just like any other day. Because we were scared of 2016, we still get together and we play games and stuff. But really, our 420s are pretty lax now. And that's because we have monitoring. That's because we have run books that tell us what to do when something breaks. And it's because we have people actively tuning these things. So even if we were all in this room together and one of those boxes went red or orange or something, we would know what to do. We'd be able to react, and we'd be able to have engineers that know exactly what to do, where to go, and how to troubleshoot it.
So some questions you should ask your team, because we want you to have some takeaways. So where should we focus our energy with our limited resources? Because everybody has limited resources, like time. How does this scale? Because as you grow as a business, you probably need to figure that out. And what keeps us up at night? Because reasons. And can we automate it? To sum up, communication is critical. DevOps is a continuous evolution of efforts Observability in metrics will guide your decisions, and you must empower your developers. And if you want to work with us, we are a tech company in the cannabis space, and we need people to help us get to the next level. And you can apply online, and we still have like 5 minutes left.
Good job, Abby.
All right. Who has questions?
That went faster.
Hi. So I'm just wondering, so you guys seem to have a handle on some of the old issues. So what keeps you guys up at night now?
Getting better metrics. So because we use Datadog used a lot of averages. So we're investigating to get better metrics. We want our 99ths and histograms and endpoints and stuff like that. And when you are limited to averages and stuff like that, it gets a little frustrating trying to lock into metrics. So metrics is our next big push in consolidating metrics too, because we have a bunch of different stacks. So I would say, and synthetic monitoring, we want to do synthetic monitoring. So these are our 2 big pushes, is redefining SLIs, SLAs, SLOs, and implementing synthetics so that we can really track that.
Can you share the slides?
Yeah, absolutely.
Yep.
One more. Any other questions?
How long did your developers fight the DevOps movement?
Can you repeat that question?
How long did it take for the adoption or your developers actually get what DevOps was bringing to the company and the stability?
That took about a year. So because we had worked with this outsourced infrastructure team for so long, it took a long time to break those habits. And like, they got, because they got used to just throwing tickets over, and it was the DevOps responsibility, and so there was a lot of friction there. And until we gave them clear expectations in that production checklist, like we want monitoring, we want you to go through these environments, we want you to use this branching, we want you to use Rancher and Docker. Like, until we gave them clear expectations, it was really hard to get that buy-in.
Any others? Okay. So what we're going to do, first of all, put your hands together one more time.